Hello everyone, I am Hamza Ali-Ou-Salah. I am PhD student in the Faculty of Sciences and Techniques in Mohammed. Today I am here to talk about forecasting hourly solar radiation using novel hybrid technique based on machine learning models. In fact, photovoltaic power generation depends significantly on meteorological parameters such as solar radiation and temperature, which are variable in nature. This variability causes the fluctuation of PV power production, which represents a big challenge for the grid operator to integrate PV systems into the electric grid. Forecasting of PV power can play a key role to overcome the challenge of intermittency. It will facilitate electric grid operation as planning, scheduling, and maintenance, which ensure the grid stability at any moment of time. The proposed global forecasting method takes place in two stages. Firstly, we will use the first model to forecast solar radiation by using the most significant lagged values of solar radiation. Then, we will utilize the forecasted solar radiation in addition to the forecasted PV temperature to develop the second model that predicts PV power. This presentation will focus on the first model that forecasts 1 hour ahead of global solar radiation. Our study consists of comparing artificial neural network and support vector machine model for forecasting 1 hour ahead of global solar radiation. The performance comparison is performed on different time scales, annual, seasonal, and daily time scales. 5 years of hourly global horizontal solar radiation data have been used in this work. These data have been collected using an epipyranometer from the meteorological station of the universities. The automated information function has been used to define the most significant lagged value of solar radiation. As a result, we have found 8 significant lagged values. The grid search technique with five-fold cross-validation method were used to determine the best architecture of the support vector machine and artificial neural network model. Statistic and machine learning toolbox of MATLAB software have been employed for this purpose. Several combinations of hyperparameters were explored to determine the best model with the lowest five-fold cross-validation error, and the best found hyperparameter are in bold as you see. Annual comparison between support vector machine and artificial neural network model are carried out using 1 year of the testing set. According to root mean square error, the artificial neural network outperformed the support vector machine. However, in terms of mean absolute error, the support vector machine outperformed the artificial neural network. In reality, comparing these two techniques appears to be challenging because the artificial neural network performs well according to root mean square error, while the support vector machine performs well according to mean absolute error. As a result, an in-depth comparative analysis of the support vector machine and artificial neural network techniques was conducted utilizing seasonal testing set to evaluate the prediction performance of each approach according to season. 1 year of the testing set is divided into 4 testing subsets which were used in the seasonal comparison. The outcome of the comparison indicates that the support vector machine gives better results than the artificial neural network in the winter and summer season. Concerning spring and autumn season, the support vector machine outperformed the artificial neural network according to root mean square error, while artificial neural network is better than support vector machine according to mean absolute error. This finding this finding does not allow us to conclude the most efficient technique for the spring and autumn season. As a result, a more comparative study based on daily testing sets is necessary to investigate more deeply the performance of each technique. Daily comparison is performed using daily testing set generated from the daily classification of global solar radiation using the daily clearness index of Evora City. For sunny days, the support vector machine outperforms the artificial neural network. while for cloudy days the artificial neural network gives better results than the support vector machine. Consequently, a novel hybrid model is created by combining the support vector machine for sunny days and artificial model for cloudy days. Figures show the forecasted values versus the measured values using the proposed hybrid technique for prediction 1 hour in advance of global solar radiation. We observe that for sunny days the predictions are very accurate, while for cloudy days the forecasts are enough good because the variability of solar radiation is very high due to the presence of clouds. Performance comparison with the existing approaches in recent literature has been performed. The proposed hybrid model outperformed the model of other study according to the statistical indicators. We conclude that daily comparison is the best way to evaluate the forecasting accuracy of machine learning algorithms. Also, the two machine learning models are complementary in such a way that the support vector performs well for sunny days and the artificial neural network gives good results for cloudy days. Further work will focus on deep learning and the recurrent neural network technique, which are very promising machine learning approaches. Thank you for your attention.